Good morning again, my friends. I didn't plan on doing two this week, but I'm by myself on this inspection, and we got more crazy stuff. 2018 build, and this is a piling and beam type foundation, which is pretty rare in my area, and also sloping lot. This home's constructed on a hillside, so we've got a lot of little stuff going on. I'm gonna try to run through this quick, make these videos long all the time, but let's show you a few things. We've got metal roof panels, and so when we come up here and look at the roof, here's one of the first things you want to look at for metal roofs, and that is the orientation of the lap. You can see here, it's called a drip leg. This is supposed to be the other orientation. This is considered an anti-siphon channel. It prevents water from siphoning over this rib and getting back down to the roof deck. So whenever you see this roof is installed totally wrong, totally backwards in its orientation. As well, these metal roof panels, this is about a 1.5 12 pitch, maybe close to a 2 12 pitch. Anything 3/12 and under, the panels, where they overlap one another, have to be sealed continuously. These are not. We've got a T111 wood siding here, and we have a transition between the sections of T111, as you see up there. That flashing, thank God there's a Z flashing there, but it has been painted and sealed, preventing water from escaping, and we can see the damage overhead. A lot of people think flashing's job is to prevent water infiltration, when it is to a degree, but more importantly is allowing the water to escape. Water's going to get behind any cladding. We need a through wall flashing to allow it to escape. Here's what really blew my mind. Walk around to the rear of this home, and this isn't going to show up good. I couldn't even hardly get a good picture of it in my report. Let's see if I can get close enough. Well, we've got a hole here, we've got damage. And when we look back in here into the wall cavity building envelope, there's no OSB, there's no WRB. Water gets behind this cladding directly to the wall framing, insulation, what have you. Nightmare. Then as well, this transition here, we have to have a Z flashing. Once again, water has to get out of this wall cavity. In a lot of areas, they've got this painted where this T111 comes down onto this band cover. Look at our damage to where the water cannot get out properly. Lastly, we've got 4 CMU block piers. Probably ran over their maximum allowable height. They would have to be filled with concrete. That's not going to be visual. But when you've got, let me step back and show you this, what we're working with here. This is so crazy. So we've got these 4 piers here on the front of the home. On this sloping hillside, geological engineers should have came out and determined the size of these footings. Those 4 front piers are carrying a lot of weight. Then they've tried to do diagonal support. Guys, look at this. 2x4s coming up in here. I'm shaking it. I don't know if you can see it. They've got all this covered up under here with OSB. But they've got it tied into trusses with practically deck screws. Then coming onto these piers with 1 concrete screw, Tapcon. That's not a structural screw. So these diagonal supports are doing absolutely nothing. Look at these 4 center piers that are touching and supporting absolutely nothing. Let me run inside real quick. Let me show you some repercussions. 4-year-old build. I have this unlocked back here. Yes. Okay. Let's come in. Let's go to this side of the home. You're not going to have a lot of indications in 4 years. This is probably going to be a slow sinking effect. But when you look at these drywall joints are taped, mudded. Yes, typical settlement. Can you get some separation of the drywall joint? Absolutely. In 4 years to have it, and let me show you some others. Let's look at this transition. Gosh, you guys aren't going to be able to see it here. We have tearing of the tape at the wall to ceiling transition. And then we've got some shear movement over here on this side. And gosh, I don't know how good you guys can see this, but this whole front or right side of the structure, what I'm calling it, there's a tear at the ceiling to wall transition. We've got indications once again of just drywall movement. So in 4 years, you're not gonna have big cracks in the drywall. Here's another. If this was typical foundation, I didn't see any deficiencies with the, with the foundation, with the full structure support. Am I gonna call this stuff out? I'll throw a little blurb in there. But when I see what I saw under here, here's another good tear joint. Look at that drywall there. I don't know how good you guys can see. I've got to figure out a better way to video. Get me a gimbal or something where I can see when I turn this guy around. Just a lot of indications of movement on the front of the home. So when you see questionable support, questionable, foundation, come inside and see what you think are minor indications of movement. You've got to take into account what you're seeing with that foundation. So here, this is geological engineer, not structural engineer, not PE. We need a geological engineer determine what was done with these footings. And at 4 years old, this is what amazes me. But there's just so many things in a 4-year-old build. Blows my mind. These are 2 engineers buying this house. Second inspection I've done for them. They came back the second time. I tell you, when you can impress engineers, you're doing a good job for your client. More to come, my friends. Hope everybody has a great day. See you next time. Bye-bye.